Hello everyone. In this video tutorial, I will show you how you can use simple Monte Carlo simulation to integrate any function using the Excel. So I choose Excel because it is very visual and I can show you how the concept for Monte Carlo simulation progresses. Now you can always do the same simulations in other programming languages too, but I do prefer Excel for at least the tutorial purposes. So let me start. So for Monte Carlo simulations, first requirement is a random number. So how will you get a random number? So if you say is equal to and then say RAND and two parentheses, so that will give you a random number between 0 and 1. So you can always modify this if you want a random number between 1 and 10, 0 and 10, then you can multiply this random number with 10 and then you will get a random number between 0 and 10, right? So now suppose I define a range. So now let's say this is my range for, and this is the range for x, and this is a range for y, right? Let me drag it here, and I'll say the lower limit is suppose 3, and for this one is 5, and for say 5, and let's say 7, right? So now what I can do is if I want a random number between 3 and 5, then I can say 3 plus bracket 5 minus 3. So I should not say 3 here, I should choose this cell so that I can change it later if I want to. So this is how it is. So now you can see, let me pull it here. Yeah, so now you can see this is a random number between 3 and 5. So this number will remain between 3 and 5. So we can do similar thing for y also. So now let's say it is x and this is now y, and I say is equal to 5 plus 7 minus 5 into rand. So now this is again a number between 5 and 7. No, so now I want to copy the same number um, to the next rows, and for that I want to keep the reference for this range same. So what I'll do is I'll put a dollar sign here, a dollar sign here, and same way I put a dollar sign. So putting a dollar sign will fix the reference, and when we move the cell, or we drag the cell or copy the cell somewhere else, then the reference would remain same. Now, so now you can see that if I drag it below, then this number is still referring to the same range, and this number is still referring to the same range, right? So let me uh, drag it down, and I'll try to generate around 5,000 points because that will give me a good statistics, but you can always choose it based on how much accurate numbers do you want, right? So these are the number of points. So now I'll also say I'll go up. Now you can see that I can change. Let me change it from 0 to 5 and 0 to 7. So now these are all my numbers. So let me try to plot XY data and see how this data looks like, because that will better give us the idea of how this scattering is. So I'll choose this and say insert. So I remove the chart title and I remove this function. So now you can see uh, it is a rectangle which ranges from 0 to 7 or 0 to 5 in x-axis and 0 to 7 in y-axis, and it is filled with random points, but because we have lot of points, so everything in the in this rectangle is been occupied. So if I click on some cell and press it again, then you can see the rectangle changes a little bit and all the number changes, but still because there's a lot of points, everything is filled up. So this is our first uh, generation of so we generated the first rectangle. And now let me define a curve. So now suppose we want to do integration for y is equal to x. So let me take you a simple example. So our function is y is equal to x, right? So now what I'll do here is I'll say um, is equal to if y is less than x, then I will use x, otherwise I will just say 0, right? And I say enter. And same way here, if I say if y is less than x, then I choose uh, y, otherwise say 0, right? So it goes like this. So then I can just double click here, so everything is copied below. So now I can also simplify it. Instead of saying if y is less than x, I can also say if this number is equal to uh, 0, then say 0, otherwise this number. So that is a I did that because if later on I modify the equation, then I don't have to modify this number, this one. I can just modify this one. So now you can see that we have certain zeros and certain numbers. Whenever there is a 0, then y is greater than x. So you can see here that y is greater than x. But here y is less than x, so I see a number here. So now let me also do another calculation, that is number of total data points. So how many uh, number I have simulated here. So I'll say 1 1. So no, I'll say 1 and I'll say this is equal to 1, and then I'll just double click here, so I'll get the 1 everywhere. But here I'll say if this is equal to 0, then 0, otherwise 1. Now here I will only get 1 when, so let me do this again. So I will only get 1 when these numbers have a value. If they are 0, then this will also be 0. So now I can say uh, is equal to sum, and I'll write it all the way down. Oh, sorry, is equal to sum. So these are total 5324 points, but if I use the condition, then the sum will be 1905. So out of 5324 points, I only have 1905 points in the condition, if which met the condition that y should be less than x, right? So let me also plot this scattered this random numbers for you, which have this condition that y should be less than x, and see how that looks like. So I'll do this, and then I say insert plot. So as you can see that y is equal to x is a straight line. So now anything which is below the straight line is being used, but anything which is above the straight line is not being used. So this in a way is the area under the curve, which is what integration is all about, right? So now what I'll do is I'll calculate this area, but I don't know how to calculate. I know how many points are there in this one. So first of all, I know the area for this uh, rectangle, and that area is equal to, so I'll say total area, that is equal to so you can see that the side of the rectangle is uh, 5 minus 0, so 5, so this will be equal to side on the x-axis and side on the y-axis. So if I multiply that, that will be the area of rectangle. So I'll say 5 minus 0 into 7 minus 0, right? So this is our total area. So our total area is 35. So now you can see that if I need to calculate the area under this line, all I need to do is say is equal to, so this many points, 5324 point corresponds to 35 area. So how much 1936 points will correspond to? So for that I'll say 35 into 1936 divided by 5324. So that is the area under the curve. So that is my value for integration. So let me also put a name for them. So we drag it here. So we write this here, and so this is total points, and this is points under the curve. And this is our area under the curve, right? So now we have this um, system where we can modify the equation and we can calculate the area under the curve. But let me also do some more modifications. So now here you can see that I am choosing a random range 0 to 5 and 0 to 7. However, if we go to more complicated functions, then I need to modify this range accordingly to the function, so that I am independent of what kind of functions do I use. So for example, let me say that instead of y is equal to x, now I choose y is equal to x square. So I have two x's now, right? So if I so for to calculate that, what I'll need to do is I need to modify these conditions. So in this condition I had if y is less than x, so instead of that I need to say is less than x square, and then I need to double click on it. So now you can see that y is equal to x square is more of a parabola. So you can see now I have a curve here, but I also get this excess area on the right side, which I do not need. So right now I am calculating all the I'm calculating the area which is under the curve, but same time for total rectangle I'm also calculating the excess area. So how will I modify this? I'll modify this by changing the range. So in this case I'll say that y, so you can see that uh, so this is our x range 0 to 5. So y range I need to modify it to y is equal to x square. So I'll say is equal to 5 square. So now you can see that there is no excess area, and you can change the range anywhere and there will not be any excess area. So now suppose if I say 44, then it is still the same, or if I say 22, then it's still the same. So now you have a way to calculate the area under the curve by using a Monte Carlo approach. So let us test whether this is true or not, or whether it is. So we need to validate it and calculate the area under the curve using the traditional integration approach, and then match the number here. So so to check this, so now we know that the function is y is equal to x square. So if we take integration of this number, so integration will be equal to x cube divided by 3, right? So you know, put here, this here, x cube divided by 3. So this is your after integration, and this is your function, right? So because our range is from 0 to 22 in x, then 0 will make everything 0, but for 22 what I need to do is say 22 cube divided by 3. That is my answer. So 3549 is my answer, but Monte Carlo is giving me 3618. So it is very close, but it is different because it's a Monte Carlo simulation. So it gives you number by randomly putting the points. So the more points you put, the more accurate your number will be. But suppose if I change a double click on any cell and press again, then you can see that the number changes, and this number will remain same because I calculated it, but our area under the curve will always change. So but this is how you can do integration by Monte Carlo simulation. So let us try to get some more complicated function just to make sure that everything works well. So let me see if I can change the range from, instead of using 0, let us do it between some other function like so 10 to 22. So I say 10 here. So remember, if I put 10, then you can see there is now I have this range. So this looks pretty good, because this is how you, if you this is what you wanted. But same way we have not modify the y here. So to modify, so if you, so to modify the y, we also have to say is equal to 10 square. So now I don't have this this. Oh no, in this case we'll not modify the y. So you can see, so yeah, so this thing needs to be remembered. So if we modify the y also, we also cut this lower part, which we don't want to cut because we want area under the curve. So we will not modify the y here. So y will always remain 0. So now let's play around with it. So in this case, uh, I need to also change this function. Let me do the calculation for integer which we did manually. So I'll say so this will be our range. So I'll say um, instead of 22, I'll give the reference of this x range, and then I'll put it in the bracket, and then I'll subtract the other x. So because now it is not 0 anymore, so when we integrate, we have to after we get the function, we have to put the upper value and the lower value. So I'll do this. So now this is our number, and now you can see that the numbers are again pretty close when you come look at uh, the manually calculated integration and the one with the Monte Carlo simulation. So now if I put it to any number, like suppose so now let me show you. So this is our curve. Yes, so let me show this. Yes, so now let's say we modify this to this number to 65.4, and this one is 55.32. Then you can see that we choose a small curve, and we are calculating the area under the curve. So manually it is 37176, but using the Monte Carlo simulation is 37464.